Okay, boys and girls, we're going to go back a little bit and do some absolute value equations in this quadratics unit, and you'll see why in 1 second. So, first, I want to go over what an absolute value equation is and kind of where it comes from a little bit more than we did in Unit 1. So, here is, here's a highlighter. Here's my absolute value equation. As we know from our shifts with the x, this means that the graph is going to shift to the left 2 from the origin. And that is what I drew right here. There's your absolute value equation. Now I'm going to show you a little bit on where this comes from and how it's kind of created. So if I just did the graph of y equals x plus 2, which is a line, with in y equals mx plus b form, so I have a slope of 1 over 1 and a y-intercept of 2. So here's my y-intercept. Here's my up 1. Here's my over 1. And there's my line. And now the other part of it is it looks like the y-intercept's at negative 2. And this slope is up 1 over 1 in the negative direction. So it would be negative 1 over 1 x. And of course it's y equals. So now where did I get that from my original? Well, if you look at it, and if I take my original, and if I multiply one side by negative 1, and I distribute the negative 1, I'm going to get that right there. And there's that line. But we know in absolute value equations that we cannot have anything below this vertex, because that would mean that the output would be negative, and we know that that is not possible. So let me make sure it's the right eraser. So that part goes away, and that part goes away. And there's our absolute value equation, and that's how it is created. Now, why is this important? So let's just say I asked you to solve for, let's say, 3 equals the absolute value of x plus 2. I want you to solve for x. So the first one is easy. That is 1, because if I do 1 plus 2, that's 3. And I would solve it just kind of normally without the absolute value. Subtract 2, x equals 1, which is this point right there. Perfect. Now, the next time you solve this, because remember, this is really y, right? So if I graph the line, we'll do green again. Now we'll do, what's not up there, we'll do blue. If I graph the line, y equals 3, 1, 2, 3, it would be here. So here's my first answer. Perfect. But there's another answer right here. And how do I get that? But this answer is not on the positive line, it's on the line we created when we made everything negative. So this is how you do it. You rewrite it again, same way. 3 equals x plus 2. Now, in this one, we made this side the negative side. But in reality, it doesn't matter what side we make negative. It's just we're making one side negative to create the opposite line. So to make my life easier, I'm going to make this negative. And then I'm going to solve. So now when I subtract 2 and I subtract 2, I'm going to get negative 5 equals x. 1, 2, 3, 4, 5. There it is. There's my next answer. Negative 5. So why are we doing this now in the quadratics unit? Because with quadratics, you're always going to have 2 answers. And with absolute value equations, you're going to have 2 answers. And so this is how you solve. Now, if this step over here confused everybody, let's just say I used this equation when I multiplied the right side by negative 1. 3 equals negative x minus 2. And I did the same process as before. I get 5 equals negative x. Divide by negative 1 to get rid of the negative. And negative 5 equals x. So whatever way you would like to think about it, you're going to get the same answer. So that's how you solve absolute value equations. I'm going to leave this one up to you guys. You're going to have to watch this video yourself. I'll put some problems on the OneNote at some point for you to practice. But this topic, I'm going to try this out. It's going to be your responsibility. I think it's pretty straightforward. And if you have any questions, you can just ask me. We're going to keep moving on in class with factoring and different ways to solve a quadratic. All right, see you guys in a little bit. Bye.